So today we're going to take a look at complex numbers, and we're going to come back to this topic in college algebra as well. So this is a little bit of like an intro to what we're doing, and we'll go a little further in depth in a month or so. But I want to remind you, if you've seen it before, and you may not have seen this before, what an imaginary unit or an imaginary number is. So the imaginary unit has the letter I, and it looks really scripty when you see it like written or put inside of a math problem. And it's defined in one of two ways. You'll either see it written that I squared is equal to -1, or that I is equal to the square root of -1. So contrary to what it sounds like, imaginary numbers are not in your imagination, right? That's not what it means. It's terrible terminology. I absolutely think it's terrible. But complex numbers and imaginary numbers are actually used in higher level physics kinds of applications, okay? So there's definitely application for using these. Definitely not where we're talking today, but these are actually used in real life. Right? So we're just going to work with them and sort of like the nuts and bolts of how to work with them today. In many ways, you're going to feel like we're doing a lot of things that we've already done. There's just this tiny little nuance to the fact that I can have a negative underneath a radical, number one. And then also at the end, when I'm combining things, I have an extra step to remember is that if I have squares, like I squares, I replace them with -1s. Okay, so there's just some tiny little differences to what we've done with just like expressions with x in them and what we're going to do with expressions with I in them. So for starters, we're going to do some very simple simplifications. If the square root of -1 is I, then if we were to do the square root of -5, what we do is we pull an I out. And because 5 doesn't have a pair, we leave it there. So the negative underneath the radical is the same thing as an I in front of the radical. Okay? And since 5 doesn't have, a breakdown of factorization, we can't do anything with it. It stays put. So the same thing is how we would begin the square root of -8. So I have I, and then I have square root of 8. But we've worked with square root of 8 before. Square root of 8 does factor, whereas square root of 5 did not. So if I'm looking at this one, I would then rewrite the 8 as 2 times 2 times 2, and I would notice, of course, that I have a pair of 2's. A pair of 2's means I can pull 1, 2 out, right? So it will go in front of the I, and then I still have the other 2 underneath the square root. Okay, 2i square root of 2. Bless you. Okay, we're always going to deal with eliminating the negatives first. So, on number 3, I'm going to take the I out from underneath the radical to leave me with square root of 3, and the I out from underneath the radical to leave me with square root 12. Okay, that's the first step. And then just like before, what happens when I multiply, for example here, I times I? It would be I squared. We'll get to the negative in a minute. So right now just write down the I squared. And then I've got 3 times 12 underneath the radical. Well, 12 breaks down, right? The 3 doesn't, it's prime. But how will 12 break down? 3 and 4 is 2 and 2, right? So I have a pair of 3's under the radical and a pair of 2's underneath the radical. So I'll pull a 3 out and I'll pull a 2 out, and then what do you see happening underneath the radical? I don't still have anything, right? I've pulled everything out. So when the 3 comes out and the 2 comes out, I have 6i squared, but there's one more thing I have to do. Do you remember over here, the definition said that I squared is equal to what? -1. So the last thing I would need to do here is to replace the I squared with -1. So what's the net result? What's the end result that I have here? it's negative 6. All right, so I squareds change signs of things. Is what they really end up doing. Okay, everybody good so far? Okay, so when I've got negatives underneath the radical, I need to pull the negative out as an I first before I simplify the radical part. Okay, we're going to do the same thing over here on this problem. So I've got a square root of negative 20 and I've got a square root of negative 2. So I'm going to pull out the I on the top and the I on the bottom. But notice what happens to the i's here. Don't leave me hanging. What happens to the i's? They're going to cancel, right? I've got one on top, I've got one on bottom. So when I'm working with division and I have i's happening, I don't end up getting any I squareds or anything like that. They cancel out just like they would have if they were x's. And then I have the same expression that I had to start with without the negatives. And I know from what we've done in the past that we can rewrite this underneath the radical together, right, as division. And what is the square root of 20 what is 20 divided by 2? It's 10. And can I simplify square root 10? I actually can't, right? It's 2 times 5. Well, I can simplify it to 2 times 5, but I can't pull anything out when I try, right? There's not a pair of anything. Good job. Okay. Number 5 and number 6 are kind of, they're very straightforward ones because you're just collecting like terms. So if you're dealing with addition, you can actually see them for where they are, right? These two terms are alike. What's 2 plus 6? 8. And these two terms are alike. What's negative 3i and positive 2i? What is it? Negative 1, right? Negative 1i or negative I? Y'all are scaring me. Negative 3i, positive 2i. Are we good?
Yes.
Okay. So it's just collection of like terms. And it's collection of like terms on number 6 as well. It's just that with subtraction, I need to make sure that I remember that I need to negate everything in the next set. I need to subtract. So I find it easier to go ahead and do one step of rewriting and distribute that negative. So I've got negative 6 and then I have positive 6i. Does that make sense to everyone? Okay, then I can do the same thing I did on number 5. What other term is the like term to negative 4? Negative 6, and that gives me a negative 10, right? How about 2i and 6i? 8i. Okay, so we've talked about simplifying radical expressions. They've got negatives in them now, right? We've talked about adding and subtracting expressions that have I in them. Where do you think we're going next? Multiplication, you're right. So I've got a couple examples for multiplication and how they work. Again, it's very, very similar to what happens when we have an x in the problem, but there's something at the end that's a little different. Number 7. Have 5i times 2 plus 3i. So what do you think I'm going to do with my 5i? Distribute, you're right. So what is 5i times 2? 10i. And then what is 5i times 3i? 15i squared. Okay, so if these were x's, if these i's were x's, I'd be done, right? Shake your head, yes. Yes, we would be done. Why are we not done here? Because I have an I squared. Yes, an I squared is negative 1. You got it. So if you just want to replace it and write it as subtraction, that's fine. If you need to see the replacement itself and you need to see this term, then write that term. Okay? So either way, whether you go straight from here or whether you do the step I just wrote down and go next, you're going to end up with 10i minus 15. All right, what are you going to do on number 8? Distribute, yeah, do it. All right, everybody distribute. Let's check and make sure that we all got the same thing, but do your distribution and then simplify it as much as you can and check with the neighbor. Okay, if you're done, see if you and your partner or someone nearby you, before you, behind you, something, if yours match. Okay, somebody walk me through what you did for your distribution. What are your pieces that you got? Okay, so that would be 6, right? And what, Sarah, you would go ahead and do it.
2 times negative I is negative 2i. 2i times 3 is 6i. 2i times negative I is negative 2i squared.
Okay, pause there. Is everybody good so far?
Yes.
See all the pieces? Okay, keep going, Sarah.
Then, well, I go ahead and change my I squared to negative 1.
Okay, we're going to do that at some point. You can do that here if you'd like.
So I make it, well, a positive 2 at that point.
So you get a positive 2 at the end.
And then I combine negative 2i and 6i, so it is 4i. And then 6 plus 2 is 8. So then it's 8 plus 4i.
Looks good. If you did it in a different order, if you combined the i's before you did the I squared, is that okay? Yeah, it's totally fine. Totally fine. Okay, so that's what multiplication looks like. Basically the same, right? There's just this extra I squared equals negative 1 portion of it to remember. And so what's our last thing? Division. So before I flip my screen, I want you to keep remembering that I is equal to the square root of negative 1, right? So if we have division that looks like 3 over 4 plus I, let's just say we had that. What it really means is I have 3 over 4 plus the square root of negative 1, right? That's what it means. So pause with me to think. What did we do when we had square roots in the denominator and we had something like this and we were told to simplify? Do you remember? We can't divide by it because it's all in 2 different pieces. We multiplied by something. Do you remember what we multiplied by? Not reciprocal. There's not a reciprocal going on. You're really close. Con something. Can somebody help her out? Conjugate. Who said that? L'Oreal. Very good. It's the conjugate. So we had conjugates when we had square roots in the denominator. Do you guys remember that? Okay. So the same thing is going to happen when we have i's in the denominator, because I is just another way of writing a specific kind of square root. Everybody good with that? Okay, so that's why it's happening here like it did before. So when I have 2i over 3 plus I, what I'm going to do is, my goal, if you will, is to get the i's out of the denominator, just like the goal before was to get radicals out of the denominator. And we do that with conjugates. So what do you suppose the conjugate of 3 plus I is? Yeah, it's 3 minus I. And if we do it to the denominator, of course, we also have to do it to the numerator. So we have multiplication in the middle, of course, of our division problem. I'll distribute my numerator, so I get 6i, and then what? Minus 2i squared. Good deal.
Why did you get 3i at the top?
I didn't get 3i, I had 3 minus I.
Yeah, you 3 minus why how'd you get that?
It's the conjugate of this. So if you remember, conjugates are the same pieces with the opposite sign in the middle. Okay, the same terms from the binomial, opposite sign. Okay, and the reason that we want that, and the reason that's the conjugate, or the reason it's conjugate is like valuable, is because what happens down here is that these are actually something that we have now called a difference of squares. So when we multiply them, we end up with just the first term squared. So what's 3 times 3? 9. And then we have the last terms times each other. So I have negative I and positive I, which is negative I squared. And again, it's not that I'm not doing the inside terms like this one right here or this one right here. It's that if I try to do them, they actually are the same value and opposite signs. So they add to 0. Can you guys see that from those values there? Cool. All right, so we've got a couple of I squareds going on here now, right? So I have 6i and I have I squared here is negative 1, so it's going to change my negative 2 to a positive 2. And in the denominator, this is an I squared as well. So instead of minus I squared, I'm going to have plus 1. The signs switch when I have I squareds involved. So I have 6I plus 2 over 10. Am I done? We need to reduce, absolutely. What can we reduce by? By a 2. Now, we have to be careful when we reduce this one. Here's a 3. Here's a 5. Don't just mark that out and think it went away. What is it? There's something missing. Plus 1. Remember, it's division, right? I'm dividing everything by 2. So the 2 is divided by 2 to give me 1. So the numerator does have 3i, but it's 3i plus 1 over 5. Okay? No i's in the denominator. That's the gist of it. So let's try the next one. Is there an I in the denominator? Yes. So what am I going to multiply by to make that not the case? The conjugate. Yeah, conjugate. What would the conjugate of 4 plus 2i be? 4 minus 2i. Okay, so the numerator is always the more detailed of the problem to multiply out. So let's multiply the pieces together. Let's multiply 2 times 4, which gives me 8. And then the 2 times the negative 2i gives me minus 4i, right? I just multiplied my 2 times everything. Oh, sorry. I didn't actually, did I? What was it doing? Oh, no, it was 4i. I was looking at the other term then. Minus 4i. And then I'm going to do the I term. So the negative I times 4 would be negative 4i, another of them. And the negative I times negative 2i would be what? Close. It's positive 2i squared. Because I have a negative here and a negative here that are being multiplied, right? So it's positive 2i squared. We'll simplify the numerator in a moment. Let's look at the denominators. So again, difference of squares, the whole point is that if I multiply the first terms, 16, and then if I can multiply my second terms, 2i and negative 2i, to give me what? Negative 4i squared. And I don't have to multiply the inside and the outsides because they're exactly the same and opposite signs, right? They add to 0. Can everybody see that okay with my numbers? Okay, good. So these two combine, right? I'm going to do that first. What happens when I combine negative 4i and negative 4i? They don't cancel out. Good. What do we get? Somebody said it over here, I think. Yeah, Megan's right. It's negative 8i. They're both negative, right? It's not one negative and one positive. And then I have the 2i squared over 16 minus 4 times I squared. All right, but I squared is equal to? Negative 1. So this is 8 minus 8i. What was a positive 2 at the end is now going to be minus 2. The 16, and what was a minus 4i squared is now going to be a plus 4. Okay, what's the numerator simplified to? 6 minus 8i is correct. And the denominator is? 20, right? 16 and 4, 20. What else? Yeah, everything's divisible by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4, and 20 divided by 2 is 10. So my final answer is 3 minus 4i over 10. Any questions?